Here we have our next example, a 6 meter beam with 3-point loads applied to it, and we're going to work out the reaction forces. First move will be to draw our freed body diagram and to label the forces. In this beam, I'm going to start at the left hand side and call that point A, point B for the 25 kilonewtons, point C for the 10, point D for the 5, and the end of the beam with the lower support, we'll call that point E. So when I come to draw my freed body diagram, put in the associated forces, VA and HA, put in the applied loads, 25, 10, and 5. Then the last reaction, I'm going to call that VE. Remember, we're going to apply the three equations for equilibrium, namely all the forces in the x direction must add up to give you 0, all the forces in the y direction must add up to give you 0, and moments about any point must add up to give you 0 for equilibrium. Remember the sign convention? Forces up are positive, down are negative, to the right are positive, and to the left are negative. For moments, clockwise moments are positive, anti-clockwise moments are negative. Taking the first of our equilibrium equations, all the forces in the x direction must add up to give you 0. We only have one horizontal force, it's HA, it's positive, pointing to the right hand side. For equilibrium, it must add up to give you 0, therefore your first reaction, HA, is a value of 0. Now apply the second equilibrium equation. Forces in the y direction must add up to give you 0. So going from the left hand side, we have VA, positive, going upwards, minus 25 going down, minus 10 going down, minus 5 going down, plus VE at the end must add up to give you 0. Rearrange the equation, VA plus VE, bringing all the numbers together gives you a minus 40 equal to 0. Then rearrange or move the 40 over to the other side, makes it a positive 40. So with this equation, if we can work out one of the reactions, we can easily work out the value of the other one. Now applying the last equation for equilibrium, moments by any point must add up to give you 0. Moments is a force by distance. We must specify which point we're taking moments about. We usually take moments about the first support we come to. In this case, I've labelled it point A, so it will be A with a bent arrow over the top, the shorthand version. And looking back at our free body diagram, HA, VA, their distance is 0, so it won't produce a moment. What does produce a moment is the 25 kilonewtons, the 10 kilonewtons, the 5 kilonewtons, and VE, the last reaction. So now I'm going to write down the force and the distance from point A to each of the relevant forces. So starting off, the 25 kilonewtons, and it is half a meter across to the 25 kilonewtons. So you can see this from our diagram, initial diagram. 25 kilonewtons, it's half meter across. The 10 kilonewtons, 3.5 meters across from point A to point C. The 5 kilonewtons, it's 5 meters across, and then VE is going to be 6 meters across. 25 times 0.5, 10 times 3.5, 5 times 5 VE times 6. They must all add up to give you 0. Now we must consider clockwise moments or anti-clockwise moments for each of these. Remember, clockwise moments are positive, anti-clockwise moments are going to be negative. So going back up to the free body diagram, remember, consider each force as though it were on a piece of string. Holding the piece of string at point A, how would each force rotate around that point A? And for the first one, 25 kilonewtons, it will want to rotate round clockwise, and therefore it will be a positive moment. The 10 kilonewtons, again, hold it at point A. How would the 10 kilonewtons want to rotate around point A? It would want to rotate around in a clockwise manner, therefore it's a clockwise moment, positive. 5 kilonewtons, again, hold it on a piece of string at point A. 5 kilonewtons will want to rotate around in a clockwise manner, therefore will be positive. Finally, VE, hold it on a piece of string at point A. How will the VE force want to rotate around point A? It will actually want to rotate around in an anti-clockwise manner, therefore will be a negative moment. These signs can be updated into our equation, and then it can be worked out. So we should have 12.5 plus 35 plus 25 minus 6 VE equals 0. 72.5 is equal to 6 VE. Then divide through VE, and we get the first reaction to be 12.08 kilonewtons. Then applying the last reaction or equation we had earlier, VA plus VE equals 40. Substituting in our value of 12.08 and rearranging the equation, take the 12.08 over, making it negative. We find that our VA takes a value of 27.92 kilonewtons. And that's our other reaction force worked out. So our answers in this case are HA is a value of 0, VA is a value of 27.92 kilonewtons, and our VE is a value of 12.08 kilonewtons.